Okay, good morning, everybody. How you all doing? My name's Darren May. I'm president and co-founder of a company called Crank211. We're a digital agency that's based in Denver, Colorado. And this session is about building a web of apps. So if you're not looking for this session, you've walked a long way for nothing. I am also a Windows platform development MVP. And so I've been lucky enough to have a lot of insight into this platform as it's being developed over time. And so hopefully be able to share some of that with you today. You see on the page there, there's my Twitter handle and my company's website if you're interested in having a look. I've been developing on Microsoft technologies since 2000. Prior to that, I was a Java architect, so I jumped across when .NET was actually in private beta. And I've been working in the XAML family of products since Avalon, if anybody remembers that from the early names of WPF, one of the three pillars. I think the only pillar that actually came through in the Vista timeline. So, I've been playing with this quite a bit. Quick quiz. How many people have built modern apps so far? Okay, not that many. That's interesting. Who went to the party last night? Who wishes I was talking quieter? Sorry about that, guys. Not much I can do about that one. So, before I talk about web of apps, let's talk about the web itself. You might wonder, why talk about the web when we're really talking about apps? But the reality is the web has really inspired the next round of technologies that we're going to be talking about today. The web is huge. There's millions upon millions, perhaps billions of websites out there. And all of those websites interact with each other in a very easy, frictionless environment. And that really has been the inspiration of, okay, we need to take a new look at how we're actually going to build our apps locally and so on. If we think about the interconnected nature of the websites, if we think about the ability to call services on those sites, it doesn't matter whether it's adjacent to me or it's on the other side of the world, I can reach out and do those things. That same connectivity is available to me when I'm building apps. We can consume web services. And that is certainly true when we're building modern apps, Windows 8.1 generation, we can do that. We can download, we can upload, we can run transactions, and so on and so forth. However, when it comes to connecting to our local apps, when we switched over to the modern app environment, it became much, much harder to do so. In fact, it was pretty much a one-way fire and forget type of integration, which, from my background as an enterprise architect and working in the enterprise itself, we tend to build componentized systems. They're not just one big monolithic app. And so if we want to leverage capabilities from other apps, we were stymied by the modern app infrastructure. The sandbox they had us in really stopped us being able to do that work. So the purpose of this talk really is to, one, remind us what we actually have already, because that's the launching point from which all the new things spring. And then two, to kind of go into what's available now for the web of apps. So, linking to an app. Too quick on the clicker. So, how do I link to an app? Well, today we link to an app using Launch URI. And in reality, it's Launch URI Async is the actual method that we call. And it does exactly what it says on the tin. It launches a URI. Now, the interesting thing about this is we're not just constrained to the HTTP scheme. We can actually launch custom schemes. So what do I mean by a custom scheme? Well, custom schemes are effectively a made-up word. Instead of putting HTTP : you can put my app : and so you can leverage that capability to integrate into apps. So if I start with my app A, I've got an app and I wish to connect into another app. I can handle a click event, and in that click event, I can call Launch URI Async. It's a method exposed by the launcher object, and I can pass in a URI. As you can see here, I have a custom scheme, my app : and I also have a query string after it. This is how I would pass parameters into the application. Should I have an application that's subscribed to the my app custom scheme, then that will start up and launch for me. Great. How bad could it be? This works today. This is what we have in Windows 8 and Windows 8.1. And this is a facility we have for launching apps. We also have the share contract, but as you know, those kind of contracts and so on are somewhat deprecated. They still exist in Windows 10, but it's not going to be something that we're really leveraging in all its facets in the same way as we were. So why are custom schemes interesting? Well, the interesting thing for me, certainly, was when I was researching this, was they've been around since 1996. And believe it or not, they were actually introduced by the Internet Explorer team in Internet Explorer 3. That makes me feel old, actually, Internet Explorer 3. Well, we're on 11 now, and now we're moving on to Project Spartan, or Edge, as they call it. It's amazing how things are going. So, if the Internet Explorer gave us anything, it gave us custom schemes. Custom schemes now work on every platform. iOS leverages them, Android leverages them. They're pretty ubiquitous. For example, if you use the Spotify custom scheme, that will launch Spotify on whatever platform happens to have it installed. So that's actually very, very key to actually being able to cross the boundaries. If you think about traditionally how we would connect with other applications, you might be opening up a COM interface, querying IUnknown, and then leveraging that to integrate into an application. Obviously, very platform specific. There was no way you could take COM and run it on OS X or whatever you're going to do. So this was a significant enhancement. There are also many emerging standards. A lot of the big tech guys, such as Facebook with its applinks.org, Bing obviously has its own AppLink protocol, and Google with its app indexing approach, they're all jumping on board trying to codify and standardize these capabilities. And it's actually interesting. I was reading an article last night on TechCrunch, and Facebook has obviously a huge monetization program around its advertising, and it has the ability, if you click on an ad, to actually click to install. So that's been there today, that you could click on it and it would install an application. But what they've actually just implemented is the ability to click to install and deep link. So say, for example, you're on a page and you're seeing an ad for hotel.com, some sort of booking application, and it's showing, hey, book rooms in Chicago. You click on the ad, not only will it now download that application from the App Store and install it, it'll also start the app and take you to the Chicago hotels page. Great monetization opportunity, but we have the same capabilities in our own apps to do that kind of deep linking. However, there are problems with deep linking. It's a fairly naive implementation from the perspective of it fires that custom scheme and launches it. So imagine we were back in our app A, and we want to launch my app scheme. So there's my launch syntax, but oh dear. I happen to have two apps installed that both have claimed to implement that protocol. Now, when I'm in my operating system, I get presented with a picker. Choose which one. And I actually don't have much information being showed to me at this point to be able to make a choice. Do I need app A? Do I need Evil Twin? I don't know. I'm going to make a guess. If I click on the wrong one, my scenario may be broken, especially if we think about the context of an enterprise application where you have a workflow that's an aggregation of number of different processes, each implemented in a different app silo. If we deviate from the path, we might have to revert back to where we were at the beginning to step all the way through. Obviously not ideal. So how do we deal with that? Well, we have some enhancements that we can talk about. So this is a very, very simple app, just to demonstrate the concepts that we're talking about here. I have my launcher application. I have two buttons, Launch Bing, Launch URI, and I have Microsoft nagging me to update my account. It's interesting. Windows 10, I have notifications turned off. That one's apparently too important to be turned off. So, very simple click handlers in my code behind. Let's go and have a look at the definition for these click handlers. So if we see here is my launcher URI async, and this is opening a traditional HTTP protocol. This one is going to open up a custom scheme. So let's just run this and see how it goes. Incidentally, how many people have downloaded the latest version of the tools and the latest version of Windows 10? Show of hands. Only a few. Okay, interesting. Okay, so if I click on Launch Bing, then it does what we expect. Opens up a web browser and is showing the Bing website. The reason I ask is you've been familiar with some of the instabilities in certain the versions of the tools right now. If I click on Launch URI, what it's actually giving me now is a dialog saying, hey, you don't have anything installed locally that handles this protocol. Do you want to go out to the store? Well, no, I don't actually. What I'm going to do now is actually launch or install my first app. So this is app 1. I'm going to deploy it. Once it's deployed, if I click on app 1, you can see it's an amazing application, full of depth and breadth, and wonderful user experience. My team would be proud of me. So that's installed. Now if I go back to my launcher app and launch URI, now it goes straight into that application because that one supports this protocol. Great. However, if I now install app 2, and here's a top tip for you when you do this right now in the current versions of the build. If I tried to launch directly into app 2 from there, it would just sit there and spin at me, which obviously is not ideal. So I run it up first and cover that by talking over it so that it will launch the next time I click on it. So this is app 2, not the one that I wanted. If I come back into my launcher and select Launch URI, I now get my picker. Now, based upon the information I have here, I really don't know which one of these I'm supposed to be choosing. So that's a bit of a problem. I'm going to guess along app 2. Oops, not the one that I wanted. My scenario is broken. Woe is me. I've wasted seconds. Okay? So how do we address this? Well, the enhancements that we have introduced... By the way, I use code snippets when I'm doing demos. Main reason for that is, as you all probably know, the number of typos you make is directly proportional to the number of people looking over your shoulder. And there's a lot of you, and there's only one of me. And so code snippets are the way we're doing this. So we now have the ability to supply launcher options. So we can create a new instance of the launcher options class, and then we can specify the target application package family name property. Rolls off the tongue, doesn't it? It's just a reason to use IntelliSense for sure. Now, this package family name, again, this rolls off the tongue, and I'll talk a little bit more about how we get hold of that, but that is a unique identifier. You get 2 of them. When you do app new project, this is what Visual Studio creates for you. When you actually create and reserve a name in the Windows Store, you get a different name there, and it's more fully qualified and human readable, plus it gets a hash of a certificate that sits behind the scenes as your code signing. So don't worry about this too much. I'll show you how you get it in a second. But what this does is this concretely identifies a specific application that I'm expecting to support this protocol. Okay? So if I now run this app, and I click Launch URI, it now goes directly to the one that I want, even though I have 2 on there that's advertising the protocol. Pretty simple and straightforward. Let me just digress and leap into the other apps right now, just to show you quickly. This is how you register for a protocol. It's in the extensions section. Okay? And there's our protocol name that we've registered, and that matches the protocol that I'm asking for here. Okay? Pretty simple and straightforward. One thing I would say is when you're creating your own protocols, use a reverse naming approach. So for me, for example, I would do com.darrenmayd.launcherapp. That will reduce the likelihood of conflicts that are going to occur in the wild anyway. Then if you do get a conflict, then you're pretty sure that it's going to be a malicious app. Most evil twins aren't malicious apps at all. It's just everybody's going, oh, what protocol should I use? Oh, my app. And it turns out every man and his dog is also using my app. But in those scenarios where they are evil, then you want to obviously make sure that you can avoid that. So that is the implementation that will allow us to go directly to an app. The other thing I would quickly note whilst I'm in here is the visual editor for the app manifest in this version of the tools isn't working, which is why we went straight to the XML. So don't spend forever trying to work out what's wrong with your system. It's just not yet in place. Okay. So pretty simple, straightforward. Oh, and I should have started my timer. Oh, well. 15 minutes in, plenty of time. So here's the example of how we address it. We've got our package family name, and here's an example of a much richer family name rather than the GUID-based one that was using beforehand. Getting the package family name itself, let me actually jump back and show you that. So if we go into one of the launched apps, in the app startup, we have this .get package family name. This is the value that's returned by that. If we go and look at if we go and look at this code, it's pretty simple and straightforward. We just call windows.application model.package.current.id.family name. Okay? Again, that's why we have IntelliSense. So there's no magic there, and this isn't a secret. This is something that you can share. You know, if you want other people to be able to leverage and directly call into it. By giving this away, it doesn't make your application any more vulnerable or anything along those lines. It just makes sure that your partners can actually leverage the application. So say, for example, you're in an enterprise scenario and you have a suite of products that you want to access, then you would want to make sure you're sharing this so you're invoking the correct apps. Other deep linking improvements. So right now, we were constrained to having a URI and placing parameters on that URI to pass values into the apps. Now what we can actually do is we can send files. And so this is obviously very useful because nobody wants to take a very large image, encode it into a string, and append it on the end of a URI. It just doesn't make any sense. And to be honest, some of us have had to do that because these capabilities weren't available to us beforehand. What we now have is the ability to share a file. So we get a storage file. Everybody familiar with storage files in the Windows environment? Show of hands. Okay, only a few of you. Okay, so if you're familiar with the .NET I/O capabilities, this is different than that. You actually can't use a lot of the previous .NET file handling capabilities. You have to use this new storage file infrastructure. And the reason for this is it abstracts you away from knowing where everything is. You interact through the storage file and the pointers it gives you rather than going direct to disk. It also allows them to implement a sandboxing which stops you from reaching outside of where the permissions you're granted. So you can access your app hive, and in additional enhancements now you have a family hive for your family of apps, but you can't go beyond that. So you can't just go to some random location on the C drive without bringing up a user interface that the user can then specify where they want to go. And then you still only get a storage file that doesn't tell you the path. Okay? So that's a security feature. So how do you get around that when you want to pass these things between them? Well, the Shared Storage Access Manager gives you the ability to generate a token that represents a storage file. You can then pass that string token across on the URI into the target application, which can then redeem token for storage file and actually get that file back off the disk. Okay? So that's a very handy enhancement. We also now have the ability to query for support. So whereas previously, you know, I'd click on Launch URI, it would give me a picker, or it would tell me I needed to go to the store. I may not want that scenario to be exposed out to my end users. I may wish to turn around and say, well, if nothing's installed on here, I'm not even going to present this option, so I can disable or hide my UI elements that would activate this linked scenario. So this API allows me to query to see if there are any installed handlers of this custom protocol. We can also do this for a specific app. So we can actually turn around and say, is this specific app that handles this protocol installed? We can also do the opposite. This allows us to focus around extension scenarios. So I can turn around and see all the apps that are installed on the system that may support my protocol. So say, for example, if I'm Spotify, I might want to find all of the apps that wish to interact with me. So I can go through, pull a list in, and see those partner apps. I can also do that for a file extension as well, if I'm registered into the shell to be able to launch file extensions. Now, all of those API extensions are pretty self-explanatory. There's a couple of lines. There's nothing really fancy to them, but they do enable an awful lot of scenarios. For me, one of the most significant enhancements is, in reality, the ability to make this a two-way conversation. Yeah, that's what's been missing, I think, for building a enterprise application integration scenarios. And so the next enhancement is launching for results. So again, I've got my app A scenario. I wish to launch an app. The main difference is I have launch URI for results async as opposed to launch URI async. This is, the team always explains that this is the reason why their methods get longer and longer and longer each iteration. They start off with something and then they go, oh yeah, let's add this, oh, let's add this, and the name gets longer and longer and longer. So, pretty much the same as we've seen so far. We have our launcher options. We want to open up our app A, but now as we launched it for results, we'll wait for a response to come back from app B. App B will now be able to process what we've passed across in our parameters and with our options if we passed across files, and will be able to return back a value set to us. Now, the value set isn't a new construct. It actually was launched in Windows Phone 8.1. It really is key value pairs, and it's based around primitives, strings, ints, doubles, those kind of things. It's basically the platform's version of JSON to a certain extent. It's a property bag, dictionary, that you can pass backwards and forwards for messaging. Okay? So, let's have a look at how we do that. So what we have here is a series of apps in a project, Contoso Shop, Fabricam ShipTrack, Woodgrove Bank. These are all names we're intimately familiar with. No real trademarks have been harmed in the making of this demo. So what is Contoso Shop? Well, it is a very, very lightweight e-commerce implementation. So what it shows is a list of the four most essential aspects that we need: 4K monitors, laptops, Windows Phone, and a tablet. And it allows me to buy them, because these are the only things we want. If I click on buy, nothing happens, nor should it. I haven't put any code in there yet. And so this is our cornerstone of our scenario. We're going to start off with this application. So let's have a look at this app and see what's going on with that. So if I open up the main page, if you look in the code behind, so here are my very naive inventory management. So obviously I could integrate out to another system to bring this in, but for the purposes of the demo, it's very lightweight. All of these call the buy method, and the buy method is obviously empty at this point. Using my typo-free implementation, so pretty much the same as we've seen thus far. We have the Woodgrove URI. It's going to call our app. So the scenario is my e-commerce app doesn't know how to deal with the purchase. So it's going to integrate into another app that supports my purchase protocol, and that's going to be the Woodgrove Bank app. I'm going to specify the package family name for my Woodgrove Bank app so I can be confident I'm launching the correct one. Then I create a value set with a product name and an amount set to these values. Okay, so here's my little property bag I'm going to send across. Now, I could just as easily append that onto a URI, but I wanted to demo this scenario to you. Next one. So now I'm going to get my shared assets. So let's just hide this for a second. So what we have here is the assets folder. So I'm going into my package current installed location, and I'm getting a folder async. So this is the other thing that's embraced by the platform if you're moving away from the .NET I/O stack, is all I/O operations are asynchronous. So you have to leverage the await pattern to leverage these. So we're going into the assets product images of my current installed application. So I'm pulling out the image. I'm getting a file async, so that creates my storage file. And now I use this capability to generate the token for my image file, so I can send that across the wire. And finally, I'm going to launch for results. So I construct my launch for results. There's my URI. There's the options I've constructed. There's the input data that I'm sending across with my value set. And this is where I handle my result, my return. Okay? So result status, launch URI status was successful. Result is not equal to null, and so on and so forth. Obviously, a fairly naive implementation. You know, we're not talking about enterprise-grade exception handling here. We're just demonstrating the concept. So let's run this, and we'll see how this works. So I bring this up. Let's buy a 4K monitor. Now what happens is the Woodgrove app launches. Now the interesting thing is this launch is modal. I can no longer interact with Contoso Shop because it is now awaiting my results. Okay? So this is a pretty robust scenario. Obviously, it's not globally modal, so I can move across and do other work in parallel. Come back to this. So now I have the option to accept or decline the transaction. I'm going to authorize the transaction. Congratulations, I've purchased the app. So it's pretty simple and straightforward. And I think it creates this first step in allowing us to connect together our apps. So let me just show you a little bit about how that hangs together. So we have our launch for results. So that's pretty simple and straightforward. Let's have a look and see how the application at the other end handles this. So here's Woodgrove Bank. If I look at the app manifest, here is my registration for the extension, and we have a new attribute on here, specified always. Okay? We can also supply optional here, and if we're specifying optional, then we expect the application to be able to launch both with results and asynchronously if we just want to fire and forget. Say, for example, we had a View My Account button in an app. We probably don't want to wait for results for that. We're just going to fire it up. You can do whatever you want with it and close it down. Inside the app XAML, so how many people are familiar with the life cycle in a modern app? Okay. Show of hands. Next to nobody. Okay, that's interesting. So the idea behind these modern apps is they are designed to work across the whole family of products, be they resource-constrained mobile devices or a full-blown desktop PC. So across that range, we have a whole different series of challenges we encounter in terms of CPU horsepower, although the modern phones tend to have a lot of horsepower these days. RAM is definitely a constraint on mobile devices. Battery life is a significant constraint for any mobile device. So what we're trying to do with all of these applications is we're minimizing the amount of CPU cycles which correlates to battery life that we use on these apps. So there's a life cycle where an app is started. If it gets put into the background, it gets suspended. Now, precisely how it determines whether it's going to suspend or not is based upon the horsepower of the system in play. On my mobile phone, if it's not in the foreground, it's in the background, it's going to be suspended. In a suspended state, it stays in memory, but it occupies no CPU cycles to execute any event handling or anything along those lines. It is, to all intents and purposes, asleep. When you go into suspension, you should persist and save any state, because once you're in suspended, if the system runs out of resources, it will terminate any suspended process. Okay? So you don't get told that, hey, I'm about to be terminated, you should save something. You go, you're gone. So you need to save these things when you go into suspension. Anyway, that's a whole different topic all in and of itself. But when you go into these different events, we have these events that get fired, and we subscribe to them in the app XAML.cs file. The onActivated event is fired when we get launched, when effectively we're being run. When we get launched via the for-results protocol, the arguments that get passed in are of type protocol for results activated event args. Again, just trips off the tongue. If we have some of those, then we know we've been launched for results. So in this scenario, what the application does is it routes us to the payment page, passing in the protocol for results args information into that page. And that's how we pass this across, and this is how the application knows it's been launched in that scenario. So if we jump across to that page, we can see here's our app bar button where we clicked accept. If I just go to the code behind. So on navigated to, this is where we read in our protocol for results. So we can grab this out, pass this value set, get the product name, the amount, and so on. These demos are actually up on GitHub, and there's a link at the end of the deck, so you can go and have a look and play around with these. If I click, I create a new result set that has my status of success, product name set to the product name, and then my operation, which is my results operation, I report complete. And that's the process by which I then send a message back to the calling app. Okay? Pretty simple, straightforward there. Sure. Could we have the questions at the end, please? That would be great. Thank you. So that's really the scenario for launching an app for results. And you can see how that would tie into a number of capabilities that you would leverage. One thing that people do typically ask is, well, how performant is that? When I'm moving things backwards and forwards. Well, you do have the overhead for launching an app, so that's something that will happen. In this generation, everything is being compiled down and it is running much, much faster than it used to. So the launch times have dramatically improved, especially with the introduction of .NET Native and so on and so forth. It's making things a lot faster. So, moving on. Let's see where we're at. So, that's enabled one facet of our web of apps, that we're able to integrate with apps, launch other apps, interact with their URI. We're starting to get to the point where we're compositing together a workflow using best-of-breed components. Great, awesome. But there's another scenario that, again, if we look to the web for inspiration, web services. Web services sit out there. They're effectively headless, and by headless, I mean they have no UI elements, nothing that gets displayed. Yet they deliver and encapsulate a lot of business logic and can handle data and do transactions and so on and so forth on our behalf. Wouldn't it be great to have something like that on our local system as well? Well, that's what the team thought too, and that's why they came up with app services. So what is an app service fundamentally? Well, if you've built anything on the modern platform, which you guys mainly haven't, you would know that if you wanted something that was going to run in the background, then you need to use something that's a background task. Okay? And these are things that are generally short-lived activities that start up. They can occupy a minimal amount of CPU and memory. They do a quick job, and then they disappear. They're used for things like updating live tiles and other sort of short-lived activities. Well, we now have the scenario where a client app can interact with an app service, which is a type of background task, and we create a connection. We specify the service name, not a protocol, a service name, and a package family name because we want to use the service name on a specific application, and then we await and open a connection. Assuming that that app and service is installed on our machine, we're then going to create an app service background task. And so that's going to be there. We're going to be able to service our transactions. And there's a life cycle for that background task that's associated with our application. And I'll touch on that in a little bit more detail. What happens if I start up another app? Oh, I should say I need to send messages. So our old friend, the value set, reappears. This is how I send a message to my application once I've opened the connection. And then I'm able to set values and send a message async. And this is a query response interface in that I'm going to send something across, and I'm going to wait until I get a response that says message received. Okay? I can then dispose of my connection, and that will actually shut down the service for me. All the time I hang on to it, that service will stay around for me. Now if I open up a second app and I initiate a connection, I actually get a new instance of this task. Very similar to the way that the websites work, in that you will always create a new instance and you interact with them. The reason for this is we don't want any pollution between the two services, and we also don't want any life cycle issues. I don't want client app B to suddenly lose a connection to its background task because client app A is shut down. Okay? So, a lot of the scenarios around this are pulling data. Now, you're going to be reaching out to these other applications. You're going to be pulling that data in. The People app actually leverages these services already. And so how many people have Windows phones? Okay, at least a few more people have Windows phones. So Microsoft has actually been using this capability internally for a long time. This is how the People apps actually pull all that information across. They've had these app services in place, and they just haven't been available for us, the general public, to consume. Now they are. There are other scenarios here around cache data that they're considering using. So, for example, you imagine the scenario where you have an app that has map data on there. Right now, when you install the Bing Map control, that Bing Map control reaches out directly to the Bing Map service and pulls in its tile data and so on and so forth. That's pretty inefficient because the reality is, in most situations, we're always going to be exploring the area where we're located. And so the odds are pretty good that we've already downloaded that tile set and we've already downloaded that information. It may well be cached in our Here Maps installation, for example. So it's not particularly efficient for us to keep pulling this down afresh. So what if, instead of doing that, we actually had an app service that was implemented by the Bing Maps application? And instead of our other apps reaching out directly, we subscribe to the app service on the Bing Maps application and request that information. If it has it cached locally, it delivers it without round-tripping around across the wire. If it doesn't have it, then it pulls it, caches it, and then delivers it across to our application. So we're going to get in a situation where all our applications become much more snappy and we're not hitting our data limits as much. Another scenario that's being considered at this point is also for hardware access. So if we look at Microsoft Band, how many people got Microsoft Band? Well, a couple of people. Cool. If you played around with the SDKs, what you can do right now is you go directly to the device and you can pull in current information because you're just pulling it straight off the sensor. The device itself doesn't have much storage, so it's not keeping historical information lying around for you. The Microsoft Health app, however, gives you the ability to see historical trending, so on and so forth. I can't get to that right now, but the Band SDK team is looking into putting app services into the Health app. So instead, our secondary and tertiary applications can connect to those app services and not only get live stats, but historical trending, and we can do a lot more different visualizations, whatever else takes our fancy. So that's a pretty key scenario that app services are going to enable for us. I'm going to jump actually into a demo at this point, rather than going on through slides, because I don't want you all to fall asleep. So we are back in our shopping app, and let's run the app again. So we've had the ability to order, and we've had the ability to have this approved. So let's just go through that scenario. You see that, bang, done. Now what about wanting to track my order history? So in most of these shipping scenarios, we actually have a third party handles perhaps order satisfaction, shipment tracking, and those kind of things. So again, this is another scenario where we would have a third app installed in our environment, and we'd want to be able to query to see, okay, what's the status of my tracking? So let's have a look and see how we would do that. And of course, it would be foolish not to do that using app services rather than bringing up that separate UI. Why would it be foolish? Because it wouldn't demonstrate the scenario I want to demonstrate. So if we click on our history page, we do frame navigate order history page. So go to the order history page and look at the XAML. So here we have our ability to, we're getting our order detail. We've created a file with our order detail on it. We open our file, read it in, we serialize it, and then we call get shipping status with a tracking number. Okay? So that's what we're doing. And here's my method with my magic snippets. Is everybody familiar with snippets and how easy they are to create, by the way? Yes? No? Anybody want me to show you a snippet? Okay, a few people do. Okay. So snippets, they're just basically an XML file, and you've got a number of different things you can do with it. The simplest is you can just put a CData block in there, which is the code that you want. Then you specify your shortcut, give it a long title, and then you can go into Tools, and you have Code Snippet Manager. And this hierarchy here allows you to specify what family of snippets you're looking at. And if you look at my code snippets, for example, these are those that I've just imported from this solution. Okay? If you want to bring in some, you just import, brings up a dialog, allows you to go to those XML files and you bring them in. And it's simple as that. If you're not using them in your organization, I strongly suggest you do, especially if you want to template error handling and those kind of capabilities. It makes an awful lot of sense to do it, and it makes code reviews much, much easier if everybody's using the same code snippets. So I just throw that out there. Anecdotally, it's something that I find invaluable, especially in demo scenarios. And then anyway, you just type it and hit tab, and it puts in all this lovely code for you, typo-free. So let's just drag that out of the way. So here's our connection, app service connection. We're looking for an app service name, a tracking service endpoint. This is our app package family name, and this is where we're opening up our connection and waiting for it to get open for us. We really don't have decent error handling in this one. Obviously, your snippet should have decent error handling. If it's not equal to success, then we're going to debug and return a error. Otherwise, we're going to go to the next part of the scenario, which is we're going to create our value set, bring in our tracking number, then we're going to send message async, and we're going to await the response. Okay? Now remember, this is a headless environment, so when I create the connection, the app starts up, and it starts up the app service. The app service is now in memory, waiting for me to interact with it. Now I can send these as much as I like. Behind the scenes, a named pipe is being created. So this is a very low latency, low overhead connection once everything is started up. Okay? So you should be able to get millisecond sort of throughput through here. If it's successful, then I display this. If it's not, then I say it failed. Okay? So let's run this up. So click on order history. Now I see this is my status, and oh, it's only processing order. I'm not going to get a 4K monitor delivered to me. That's a shame. Okay, so that's the scenario. So this is pretty cool. You now have the ability to create these app services that you can deploy out in packages onto all your local machines that can now broker all of this interaction with your back-end capabilities. So you can divide up and conquer all of these various integration services and activities. And it gives you quite a granular way to manage these families of services. So that I think is pretty compelling. Before I jump back out of here, let's show you how that gets registered. So we have Fabricant Ship. This is the application. And we also have Ship Track Service. There's just one class in there. This is a WinMD component. A WinMD component is how you encapsulate a store class. It's like an assembly that you can share in the modern app world. And in effect, what they are, they're COM objects that get wrapped up in metadata that can be leveraged from JavaScript, from C++, as well as C#. So this is very, very useful. Inside the tracking service, we implement the iBackground task interface. You have mentioned beforehand that app services are nothing more than background tasks that are running. We implement that interface. There is effectively one method that we get called, which is run, and this is what happens when we start up our app service. Now, the main thing that's different here than in a traditional background service is we actually want to hang on to this. And so hanging on to something in the modern apps are achieved through getting a deferral. And a deferral is basically saying, don't kill me, I'm doing something. Depending upon what you're doing, your deferral may only last for a certain amount of time. So in the Windows 8.1 scenarios, when you're in your suspension event, that's typically where you handle saving your state, because you might be terminated. If you know that you're going to be writing to a bunch of web services, you might want to ask for more time. So in your suspension, you ask for a deferral, otherwise it would just pass straight through. And this pass straight through has been achieved by the introduction of tasks. So how many people are familiar with the task libraries that exist? Okay, a few people. So tasks allow us to do asynchronous operations. And in order to make that syntax very simple, we have this await method. Let me bring up a... So here. And we've also marked this method as async as well. That tells the compiler that it will need to do some work in here to actually create a callback behind the scenes for us. When we're running through here, execution returns to the caller at the point of this await. And the reason for that is we don't want to block our user interface or anything along those lines and make it unresponsive. So the compiler injects a return at this point and lets the rest of the application carry on doing what it was doing. The await tells the compiler, when this asynchronous method returns with a result, carry on and execute the remainder of this method, or at least until it hits the next await. Okay? So that's been done for us. It saves us. If you're familiar with JavaScript, you do promises, and you have a success promise and an error promise. It saves you chaining all of those things together, which can end up being quite a level of indenture and makes it easier to write code and see what's going on. So that's what's going on there. Now, the reason for a deferral is the deferral persists across this return boundary. That in your suspension event, if your suspension event handler returns, then the environment by default would go, oh, you're done, I can stop you, and I can terminate you at will. If you have a deferral open, it'll go, oh, I'm not going to shut you down yet. You said you've still got something you need to do. I'll wait until that deferral closes, or 10 seconds. Because that was the maximum time you had in the Windows 8 time span, was it would only give you up to 10 seconds, then it shut you down anyway. Okay? So if you're saving state, it actually makes much more sense to save as you go, rather than try and save a monolithic block to 1,500 web services in your suspension event handler. Okay, anyway, I digress. So we send our message, we wait for its result, comes back, everything's good. How does this app service get published? Well, in the host app for the app service, we have the app manifest. And again, we have an extension in here, category of windows.appservice. Here's our app service name. And we also have to supply the class and method, or the namespace rather, of the class that implements this service. So shiptrackservice.trackingService maps to shiptrackservice.trackingService. Okay? So it's pretty simple and straightforward in reality. There's a lot of complexity that's going on behind the scenes on this. Now, as developers, we often run into the scenario of, I don't know who did it. It wasn't my code, but somebody put something in here that's a bug. Yeah. I never have any bugs in my code. Do you have bugs in your code? Nope. But I often have to debug someone else's code. So how do I debug this app service that's launching behind the scenes? It's in another app, and I'm launching Contoso Shop. How am I going to do this? Well, the team itself ran into the same problem, and so they spent a lot of time working in Visual Studio to actually enable this scenario. So what I'm going to do is I'm going to make first of all, I'm going to start my Contoso shop. So that app's running. And I did Control F5 there, so it's not attached to the debugger, so that's just running away. I'm now going to set Fabricam Ship Track to be my default project, my startup project. Note it's the host project, not the component, because you can't just run the component. Then I'm going to come into Properties, going to go to Debug, and then I have this method, or this property. Do not launch, but debug my code when it starts. Okay, it's a bit of a mouthful, but it kind of says what it does. So if I hit F5 now, it's now building and deploying track ship. If I come to my tracking service, I have my breakpoint already. So now, if I click on here, so this is a completely separate app, and run order history, Visual Studio will now notice that that app has been started, will attach its debugger to it, and now I can debug my services. So this is actually, I know they had to do a lot of work to get this scenario to work as easily as that, but there you go. So now you can track through and see your arguments come across and everything along those lines. So obviously nobody in this room is going to create bugs, but you can tell other people how they can debug their code and find the problems. So coming back to our enterprise suite of apps. So this is basically the scenarios we're now enabling. We have the ability to have, say, a product scanner that implements all the low-level APIs to interact with Bluetooth devices and so on and so forth. We have an inventory app that understands how to speak with our line of business inventory service behind the scenes. We have a checkout app that knows how to integrate with payment gateways and so on and so forth. And we can compose together these orchestrated workflows using a combination of app services and launch URI for result that allow us to build these fully composed solutions that are much more granular in terms of their implementation. We just did that. So once again, this is how we debug. It's in the slides, so you remember it. It's just checking that box, but it's making sure you find the right project to go into and setting it to start up. App service lifetime. So as I mentioned, the app service is launched upon demand. It is slaved to the client app and is there for the life cycle of that client app unless you do something like dispose the connection, which will terminate it, or may terminate it. If your invoking app is suspended, so remember, suspension gets moved into the background, no CPU cycles. It terminates the app service as soon as you go into suspension, okay? So what does that mean? It means you can't assume when you come back from suspension that you have a valid connection. So don't bother trying to save your connection object or serialize that out or anything like that. It's gone. You need to create a new one in that scenario, okay? But also, if you don't have enough resources, it's not going to launch it. And so you need to handle the scenarios where your service doesn't launch. You know, handle that gracefully, say come back later, oops, whatever you're going to need to do in your organization. So to kind of wrap up, there are a number of best practices that we're really talking about here. You know, we've gone through, we've exposed up how we can now connect to apps. We can make it a two-way conversation. We could leverage UI across multiple apps if we want to. There's nothing that stops us chaining these things together as deep as you want to, though I'd suggest probably limiting it to a few steps. We can also speak to apps in a headless way and just leverage them as services to really help expand our footprint. You know, you can imagine you could have a whole, you know, My Enterprise Services app that puts those things on there and encapsulates it and makes it, and have different release cycles for these different things, which could be useful. But when you're building these things, do your consumers a favor, and by consumers I mean your fellow developers. Encapsulate the stuff into an SDK. Rather than having them having to worry about the value sets and the string names for the values, for the key properties and so on and so forth, create a nice strongly typed API for them. Put it into a class library, put it into an assembly, put it into a WinMD component. So they have a strong, rich model to interact with. Then inside your SDK, you worry about mapping to and fro from the value sets. You worry about how to what the service name is, what the GUID is, or the package family name for those things are. Encapsulate all of that. Make it simple for consumption. The great thing about that is then you can control things. Then you can ensure that there's decent error handling going on. At least you can capture logging inside your framework and then throw the exceptions, perhaps in a more user-friendly exception, out to your consumers and so on and so forth. And you can manage versions. You know, if people are interacting with that, you can deal with any changes you're making in your services. And then, hey, if you created a component, why not use NuGet? You know, everybody has it. Well, everybody with Visual Studio, anyway. And it gives you a great framework for versioning and pushing those things out and so on and so forth. You don't have to use the public NuGet. You can create your own NuGet server internally inside your organization. Heck, you can do all manner of things with NuGet. You could even use it to distribute snippets if you wanted to. The other thing to think about is now we're in the same realm as we are with web services when we start talking about app services. When you create an app service and you publish it, you've established a contract with the consumers of that app service. So you need to think about how are you going to handle evolving that app service. You know, because again, we're all perfect in this room, I know. We get our API footprint right the first time. We never have a need to iterate. But for those other people that you might know that need to cater for those scenarios where the application keeps evolving, we need to think about versioning from the outset. It's very hard to retrospectively put versioning into something. Think about your changes. You know, if you're extending the result set, okay, that's not a breaking change. You don't need to do something dramatic there. It's just another set of value sets that are going to appear in your response. If somebody doesn't need to use it, great, no harm, no foul. They can carry on. But if you're doing a breaking change, then issue a new endpoint with a version number. That way, you don't break what everybody has out there already. Okay, yes, you may need to manage a migration, that they need to move from that version to a new version, but this will at least allow you to have a new generation of products coming out that use your new endpoint whilst you retire your previous endpoints. So, recapping, the things that you'll do with this stuff. Now, with the system launcher, we can link to specific apps. We can pass arbitrary data, value sets. We can send files. And we can actually have a two-way conversation with an app that we've launched. We've introduced app services. These provide services to other apps. You have the ability to consume those services published by other apps in your apps. We've now really started to hit into our web of apps scenario. That's only going to continue to evolve. We also talked about how the platform already is leveraging these things in the People app and how we're going to see other platform products such as the map services and so on and so forth will start exposing app services that we can leverage. Cortana's using this. Hey, if Cortana's using it, we all should. The new generation of Office applications. You probably heard a lot about the Office applications at this conference, but they are dog-fooding this same technology stack in all the modern implementations of these apps. So it's the same rendering, it's the same app services behind the scenes, it's the same life cycles, the same UI. Interactive toasts. So the ability now you have, toasts used to be just passive and you would dismiss them. Now you have the ability to do reasonably complex scenarios with toasts. This is enabled through these services and these custom schemes. People contacts, photos, cameras, and of course, you're going to be using them because they're awesome. So I just wanted to briefly touch on some resources. So Arun Singh is the guy who actually coined the evil twin phrase, and he actually heads up the team that built this API stack. You can actually see his blog at aruntechtalk.com, and so he's constantly sharing source and scenarios, and he's also very, very open to feedback. Wants to understand the scenarios that maybe you can't address right now in the APIs as they've been exposed, or any limitations that you see. So by all means, reach out to him. That's my Twitter handle. Every now and again, I dribble on about something on Twitter, and that's my company website. Please evaluate the session. Everybody likes to get feedback on how well they're doing or how not so well they're doing. I'd prefer it if you told me how well I was doing, obviously. And questions. Okay, so the question was, when you're launching an app from app A to app B using the launch URI. So it's the same scenario where he's talking about the scenario where what happens if you're trying to launch for results and the other app isn't there. Well, you would basically get that picker that, hey, you don't have anything that has this in place. Do you want to go to the store to find it? That's the scenario that's there. You'd also get the failure to launch. That's actually what you'll get in that scenario because we're specifying an exact app. You would get a failure to launch on the scenario. So you actually get responses back. On launch for results, you get a response. Yep.
Regarding the family name, ID, does the store give the ID or is it something that
So the question was, regarding the package family name ID, does the store give it or does it come from the Magic? It comes from Magic when you do File New App. Visual Studio creates a GUID that it uses as a temporary package family name whilst you're running locally inside your development environment. When you go onto the App Store and you reserve a name for your app in the App Store, that is when a package family name gets created, and it also gets hashed together with your certificate. Once you've actually connected your app in Visual Studio to a provisional publishing profile in the App Store, your app then gets that package family name. Okay, so that's the one that you'll use in the real world, and once you've hooked those two together. But all the time you're in a development scenario, it's just a GUID with a temporary cert hash stuck on the end of it. Does that answer your question?
Yes.
Great. Anybody else? Sure. So the question is, how are they secured? Well, the reality is we don't have a web server running on our system. So this is all being managed through shell level integration and so on and so forth. So you're in the operating system at this point. So it's not a protocol that you could put a sniffer on or anything along those lines. So from a local app perspective, you're good. Now, if we're doing a launch URI, which is going to http.bing, then obviously we're going out to the web and we can't control beyond that. Does that make sense? Sure.
Calling the app directly using this GUID that is created, why using a custom protocol?
If I'm calling an app directly, why am I using a custom protocol? Because I have no actual way of calling an app directly. I cannot launch, within a modern app, I cannot launch an app. I have no way of knowing what's installed. I can't go to program files. I can't do a process run or anything along those lines. This is my only mechanism to actually initiate some form of external action with an application. It's part of the sandbox of modern apps. Hello?
when you showed the other app launching, there is a broken cancel button. Is it coming from the OS or is it part of the app?
So the question was, when you launched the Woodgrove Bank app, there was a OK and a cancel button. Was that coming from the environment, or was that something that was built in the app, correct?
Yes.
It's something that's built into the app, and it would be a response. So if I hit cancel in that Woodgrove Bank app, the response, the activity was still successful in that we went out to an app, we connected successfully, and it sent back a valid response. The payload in there would just say that the user elected to cancel the activity, and that's a business payload. It's got nothing to do with the integration scenario. So it would be a successful integration scenario with a message that said the user declined to make the purchase. Does that make sense?
I think the follow-up question is, can we make that app coming within our app? Because I don't want to have a second app coming up on...
No, we cannot, because we're launching another app, and it's running in its own sandbox with its own UI constraints. We can't embed that app physically within our UI. That may be a scenario that's explored in the future, but presently that app starts up. We're not composing our UI together and creating it. So right now we have that modal behavior which stops us from switching back to the app behind. Woodgrove is going to stay on top of us and limit us from doing that activity. Any more for any more? Well, great. Thanks ever much.